Call the meeting of the Energy Finance Policy Committee to order. Today is Thursday, April 9th, 2026, and we have a quorum present, I believe. Representative Sexton, would you like to move the minutes from March 26th?
So moved, Chair.
Rep. Sexton moves the March 26th minutes. Are there any additions or corrections to the minutes? Seeing none, all those in favor say aye. Aye. All opposed say nay. All right, the motion prevails and the minutes are approved. All right, our first item on the agenda is House File 4770. Representative Mekeland, if you want to make your way up, if you have anybody that wants to join you up at the testifiers table, please move your bill.
Thank you, Mr. Chair. I would like to move House File 4770.
Representative Mekeland moves that House File 4770 be put forward the committee. You have an author's amendment, Representative Mekeland.
I do have an author's amendment. It's just a few technical changes and inserts the actual dollar amount. If we can move the A1.
All right, Representative Mekeland moves the A1 amendment to get the bill in the shape that he would like. Is there any discussion? All those in favor of the A1 amendment say aye.
Aye.
All opposed say nay. The motion prevails and the amendment is adopted. Representative Mekeland, please present your bill.
Thank you, Mr. Chair and members. This is a very important thing that we are chasing down here. We need to get a plan put together. This extends from the closure of Sherco. Sherco currently provides the steam to Liberty Paper, and I have a testifier who will explain more about that here in a minute. But we had one of these last year. I think it was Representative Tabke had one of these, and they came up with the idea of, rather than just having a gas plant or something to create steam or electric, they could do this with a renewable source. So I'm going to let my testifier explain all this complex, fun, anaerobic digester stuff.
All right, I believe we have Jim Morgan, President and CEO of Liberty Diversified International. Jim, if you'd like to introduce yourself for the committee. And
Thank you, Mr. Chairman, and members. My name is Jim Morgan, and I am the President, Chief Executive Officer of Liberty Diversified International, headquartered in New Hope.
All right. Okay. Feel free to share what you know.
A little bit of background. I'll be brief about it. Liberty Diversified is a 108-year-old, fourth-generation family business founded in Minnesota. And headquartered in Minnesota today. We have 6 operations in Minnesota, Golden Valley, and these are packaging plants and a paper plant, and also we're an investor, a partner in Demcon's recycling facility. Those facilities in Brooklyn Park, Golden Valley, Anoka, Ramsey, and Becker employ, and we have about 700 team members in Minnesota, and it's a proud family business that loves their Minnesota heritage. So, Liberty Paper, founded in 1995, is a recycled paper mill in Becker, Minnesota. We recycle about 1,000 tons a day of recycled paper, so principally old corrugated containers. That 1,000 tons a day is then converted into roughly 800 tons a day of paper, which is used for packaging, principally in our packaging plants in Minnesota and the Midwest. We selected the location for a number of reasons, obviously, with Becker, but because of the proximity to Sherco, we were able to put together a very interesting and very mutually beneficial relationship. We take about 875 million pounds of steam that would be excess steam coming off of their generation capability. They transport that to us. We use that for motive steam and for thermal steam in the paper making process. We then condense that steam and send it back to Sherco in a usable fashion. That closed loop system has worked for many years and has been really beneficial for both parties. And so the committee knows we're still working very hard with XL to see if there are other options and other things out there, but we are pushed a bit on the time, and that's why we're here today. With the impending closure of the third Sherco facility December 31st, 2030, we're a bit on the clock. We expected this process to do the research, the development, engineering, permitting, construction, and startup will take us somewhere between 4 and 6 years for a facility like this. We're looking at some innovative technologies to get sustainable, renewable energy, and recognizing that we're also prepping ourselves for 2040. The facility in Becker employs 150 team members. Their compensation is average about $90,000 a year. We're as active in the Becker community as we can possibly be, and we've got support from the Becker team to move forward. This is technology that is somewhat proven technology. As you may know, DEMCON is installing an anaerobic digester now. Construction started several months ago in Shakopee. This is also technology that's been used in the pulp and paper industry before, and we feel that it's technology that could be very applicable for this project. We're asking for some funds to do the study and demonstrate which of these processes is capable. We need to understand feedstock, raw materials, et cetera. So, we've asked, and we do appreciate you listening to us, and hope we can be successful here.
Thank you, Mr. Morgan. Is there any, do you have more, or are you?
No, sir.
You appear to be ready for a question or two. Sure. Kind of just from a thermal loss standpoint, so if you're bringing steam in to your plant from Sherco, and then you're returning that compressed steam back to Sherco, kind of what is your, how many BTUs are you using, as it's coming in, as far as your heat that you're able to, while it's still, and shoving it back through? Are you reheating the steam while it's within your possession, or are you using it as is?
The translation to BTU is very difficult because a lot of this is used as motive steam. So we're actually moving paper machines around. We're heating water. I don't want to guess at the BTUs. I can get that information for you with no problem.
Sure. And then just a follow-up to that. So if you're thinking of doing something from a replacing natural gas or whatever, is the project, you do have a plan to supplement, or are you looking that this would be a self-contained unit, essentially off-grid system that you're looking to potentially develop?
We don't know the answer to that, which is principally why we want to do the study. We're not certain. We don't know whether we have enough feedstock for a digester. We don't know whether there's enough combustible construction demolition waste or biomass available to stand alone. I have personally in my past built a very large biomass facility which was a standalone. We expect at this point that this will be a standalone. Depending on the technology, it may need a little bit of assistance from another technology. So,
sounds good. All right, thank you. Representative Hollins?
Thank you, Mr. Chair. And thank you for bringing this forward. Yeah. I'm a big supporter of anaerobic digestion. I carried some bills to fund the one that's in Shakopee, and so in general, I think this is a great idea. I guess my question, though, is, and I fear that maybe the chair asked this question and I missed it because I was talking to the people from Ramsey, Washington, because I was asking how much, I was asking them, like, did you do a study beforehand? How did you decide to do this? And they said, no, we just jumped in and did it. And so I guess what I'm asking here is, because it was a long, difficult process for them to secure the matching funds with DEMCOM to get that done. And so my question here is, as we're looking at, $750,000, right? Is that something that how necessary is this study, I guess? And then also, because I would rather just put the money towards a project. I'd rather put the money towards your project, frankly. Mr.
Morgan.
Yes. Yeah, I'm sorry. The study's critical because, for example, at DEMCON, right now they have commitments for 75,000 tons of food waste going into the facility a year. We don't know whether we can get 75,000 tons of food waste into Becker, and economically. So we've got to do a feasibility study to say, what is the cost of fuel going to be? How are we going to be able to process it? And then obviously, as we process it into steam, how much? And we may actually process it to steam and power. We may do a turbine on top of that so that we can produce power as well. Since we have the steam and it will be at high pressure, we can run a turbine and produce power as well. So the study's critical because we really have to understand the feasibility, and these technologies they're proven technologies, so they're out there. We obviously have direct access to the DEMCON data. We're partners, so and they've been very willing to share with us and give us ideas. So we didn't just jump into it. What we did, and we've been, by the way, we're still working aggressively and collaboratively with Excel to see if there are any other options we can come up with, that would meet both the needs in 2030 and the needs in 2040.
Representative Hollins, follow up.
Thank you, Mr. Chair. Okay, that's really helpful. And the other thing I was thinking when I saw this was I was thinking about a Representative Kraft bill that takes waste heat from wastewater treatment plants. And I was wondering if that would be an option that could be considered in Becker as well.
We have a small wastewater treatment, I'll say small because it's not a municipal-sized wastewater treatment plant, but we do have a wastewater treatment plant at the paper mill, and we do off-gas. We're right now in the process of using that off-gas for we're looking at a number of applications, but to use that off-gas in the facility. That project is ongoing. We'll install equipment probably within the next 9 months that'll take that. It's not a lot of gas because it's not a lot of water, but yes, we're going to take that waste gas and utilize it fully.
And Mr. Chair, as far as
yes,
like the other
Representative
waste,
Mekeland.
the wastewater is not, for the city itself, is not anywhere near there. Yeah, it's miles away.
Representative Hollins, follow up to that. Representative Jones.
Thank you, Mr. Chair, and thank you, Representative Mekeland, for bringing this bill. Like Representative Hollins, I do like anaerobic digestion, so this is really intriguing. So thanks for bringing it forward. I had two questions, and I'll just ask them now, and you can give the full answer. So what would you do if you don't receive this money regarding this project? And then secondly, can you explain more about what types of fuel stock you're looking at and what you would be doing with the end of the material? Is that part of the research that you'll be doing?
Sure.
Mr. Morgan.
I'm going to try, I'll take the questions one at a time. What do we do if we don't get the money for the study? So everyone's aware, we've already paid a significant portion to hook up to the auxiliary boilers at Sherco. We paid that a number of years ago. We've agreed with Excel to pay $1 million to hook up to Sherco 3 in the event that Sherco 2 goes down before Sherco 3. So we're continuing down that process of trying to give ourselves as much time on this process as we can. There's always an option around a gas-fired boiler. That technology is there. And we're talking with Excel about firm gas supply, but we also want to think ahead. Family businesses make these kinds of strategic. We're going to make a fairly significant investment in Becker, but we have to make sure we have the steam to do it. And I, the family that I support, looks at investments that are generational investments. And so we think about the 2040 bill, which is fully carbon-free, and we want to think about that in this process as well. And I'm sorry, the second question was?
Representative Jones.
Yeah, thank you, Mr. Chair. So the other questions were more about like what will you be looking at within the study, what types of fuel stock, and what will you be looking at, what to do with the residual material at the end of its use?
Yeah, we're going to be
Mr.
looking
Morgan.
at. Oh, sorry.
That's all right.
You got to hesitate a little bit. We consume about 1,000 tons of old corrugated containers a day, and there is an we'll call it an offshoot of that. So some of it goes fiber goes directly into the paper mill. We make paper out of it. There are some residuals there, so we would start with that as a residual material. And then we would look at things as they have it at DEMCON and others. We'd look at food waste. There's a significant amount of food waste that's going into the landfill because there isn't a way to other than composting it, which is an option. There really isn't a way to beneficially use that product. So we would look at food waste first because that's a proven technology. It's a digester. Essentially, it generates a combustible gas and it generates char. The char that it generates, and you all maybe probably already know this, and if I'm repeating something you already know, I'm sorry, but the char is a perfect carbon capture. So we look at that technology as a really ideal technology. So we're going to look at food waste first, then we'll look at if we can't get enough or we can't feasibly get enough, we'll look at biomass. And biomass could be anything from agricultural products, which frankly, around Becker, we've got a good bit of them. So we've got agricultural products that would otherwise be plowed under, that we can recover and we can consume. There's construction and demolition waste, which today goes to the landfills. We happen to sit next to a fairly large landfill. While I wouldn't initially propose mining the landfill, but diverting from the landfill products which can be consumed and to generate steam and energy would be the next one. And it may be supplemented by some sort of natural gas for a period of time.
Representative Jones.
If I may.
Representative Mekeland.
Thank you, Chair Swiderski. The landfill he references, it's a construction debris landfill that the only two things you can dump there is construction debris and food waste, because the food waste helps break down the construction debris. So it is kind of a unique thing, happens to be sitting right next door. Thank you.
Is it, all right, Representative Sexton.
Chair, I guess my question is going back to Representative Kraft's bill. The use of the wastewater, not the off-gassing, was what I believe your bill addresses, correct? The temperature increase of that, my understanding, is only about 50 to 80 degrees Fahrenheit. Would you have a use for that in your facility, water temperature like that? It seems like you need steam.
Mr. Morgan.
I'm sorry, I did it again. Both, because we obviously, in order to take old corrugated containers and make them into fiber to make them into paper again, we've got to take them down to about 0.5% solids, which means we're adding water, thermal energy and water, and a mechanical energy to essentially pulp it up. So we do need significant amount of water. Any water that has a temperature to it is a benefit to us because we don't have to heat it up. And then when we have hot water in the facility, we'll put heat exchangers in so that we can take that heat and use that heat beneficially. And that allows us to manage the water. We recycle the water as much as we can inside the facility.
Okay, thank you. Nothing
Representative
further.
Sexton.
Nothing further, Chair.
Is the, I've seen the cauldron there where you kind of do your main dump. What, is there kind of a temperature fluctuation that you can still be efficient in the breaking down? When you say mechanical, it's just an agitation, correct? And then is there kind of a temperature range that the plant can operate sufficiently for a pulp breakdown?
Yes, there is, and there's actually different technologies to do that. We're considering the installation of a drum pulper, which uses significantly less water, and it doesn't do it at heat. So it's a much more efficient process than the older technology, which is what you saw when you visited the mill. A lot of paper mills can operate at differing temperatures, and it's really about the technology that's installed. Some can actually even operate at ambient. We can't, but some can.
Any other questions? Is there any, Representative Mekeland, do you have any other testifiers?
I do not.
Is there anyone from the public that would like to testify for this bill or with concerns? All right. Members, also please note that there is some written testimony in the materials in support of the bill. With no questions, there's that page. Representative Mekeland, do you have any final comments?
So
Your bill as amended.
I do, actually. Thank you, Mr. Chair. In part, this is all instigated because of the shutting down of Sherco. But if this facility, if I'm correct, they're the ones that supply all the stock paper, if I have this right, to the rest of these facilities, or most of them. And so if this one goes down, they all go down. And that is, I don't remember the number, a couple hundred union jobs in Brooklyn Park and Golden Valley. So that's where this is such a catalyst, and it's more than just Becker, because it affects all the other plants, because they're the stock supplier for everybody else. So Thank you, Mr. Chair.
Chairman, can I respond to that quickly?
Yes, Mr. Morgan?
He's absolutely correct. We use the paper produced in Becker to produce boxes in a number of facilities, including Golden Valley, which is a Teamsters facility, and Brooklyn Park, which is the steelworkers. And they're uniquely interested, as you might imagine, in making certain that we've got a long-term supply of paper effectively produced in Minnesota.
Mr. Morgan, could you put it in perspective? Like, I think most people understand what a pallet would be, like a 4 foot by 4 foot by 4 feet tall. Could you put that in perspective when you're talking about weight and cardboard, when you're talking about 1,000 tons a day, and what that means when it comes to kind of a fluffy, light product?
Yeah, obviously, depending on the product that goes on a pallet, typically you're looking at, somewhere between 200 to 400 pounds. We use 1,000 tons, so a day. And we tend to walk out, and people say 1,000 tons, it doesn't seem like a lot, but when you walk out and you see it sitting there and you say, that's how much corrugated we bring out of the waste stream. So as you take the corrugated box out and put it at the end of your driveway, if you're in Minnesota, that box almost certainly ends up back in Becker, Minnesota. And it's a significant amount of corrugated.
Mr. Morgan, how much, so just for, like, let's say the 7-county metro, so when there's a recycling program that we hear about in general, what percentage of that is captured, do you think? And then, do you think 90, 98%? What would you say is your capture number?
The industry data would tell you on corrugated, it's about 90%. But we also consume mixed office waste, something coming out of the office, any kind of fibrous product that we have, we'll consume. We have to clean it differently, we have to treat it differently, but typically the industry says about 90% of the corrugated boxes are recycled. And, our facility, I shouldn't say our facility, it's STEMCON's facility, we're just a partner, but, they provide, every corrugated box that they recycle comes directly up to Becker.
All right. Well, sounds good. All right. Thank you, Representative Mekeland. House File 4770, as amended, is laid over.
Thank you.
All right. The next item on the agenda is a presentation from Dr. Joel Lynch from the Centerpoint about energy use, heating demand in Minnesota. Mr. Lynch, if you would like to make yourself comfortable and at the testifying table and begin your presentation, that would be great. Do you have something to plug in?
Yes, I wasn't sure if the presentation was already up and ready to roll, or
I don't know.
we need to plug it in.
I think we're good. You can take a moment to get ready to rumble. It's fine. There we go. That's nice spot. Sounds good. Some energy thing we need to study there. That's nice.
I don't know why it's.
You need to do Windows P. There.
Awesome.
All right.
Thank you, everyone, for your patience. Sometimes I can be a little technically challenged.
Great. Madam Fiske and Mr. Lynch, if you guys would introduce yourselves as you speak for the committee, and we look forward to your presentation. Thank you.
Thank you. Good afternoon, everyone. Appreciate your time today for the committee. My name is Jamie Fitzke. I'm with Centerpoint Energy, and with me today is Dr. Joel Lynch with Centerpoint Energy. The obligatory opening slide, Centerpoint Energy is Minnesota's largest natural gas utility. We serve over 940,000 customers in Minnesota. One thing that I always enjoy highlighting is that 3/4 of our workforce is unionized, plus our contract workforce. Understanding that this session, affordability has been a key focus for the committee, and it is also a key focus of Centerpoint Energy. Wanted to just highlight this slide to first address that 55% of a customer's cost through us is the natural gas cost. The cost of natural gas is passed through. And I just wanted to highlight that picking out one random day in August or February isn't an accurate picture of the cost of gas, and wanted to clarify how we achieve our goal, which is to provide and acquire the cheapest BTU to put in our pipes and to send to our customers. We first do this through energy efficiency. By using less, it's less expensive. We've had nation-leading energy efficiency programs for over 30 years. We also do this through contracting. This enables price stability over a longer term. We have storage, so we utilize reservoirs to store natural gas, which we purchase in the off-season, and then it's dispatched. We additionally have peak shaving facilities. This is used due to capacity or cost constraints, and then also curtailing and conservation. So I like to think of this as customers who have had a pre-agreement to a demand response, and with media outreach when we can ask our customers to conserve. So we actively employ these strategies to help keep our customers warm with reliable and cost-effective energy. The second part I'd like to highlight is the other 45% of that pie chart. So this refers to non-natural gas items. So think of that as like our infrastructure, operation and maintenance, and the programs that we offer. As you can see, these other components that make up the customer's bill are substantially lower than the national average. And that's something that we're really proud of here in Minnesota, given the fact that natural gas is really critical during the winter to heat, that we are below the national average when it comes down to cost. So with that said, I would like to introduce my colleague, Dr. Joel Lynch. He's an energy efficiency engineer at CenterPoint Energy. He joined us in January of 2025. He has a doctorate in mechanical engineering from Iowa State.
Good afternoon. My name is Joel Lynch, and I wanted to thank the committee for the time today to present. The title of my talk is Peak Heating with Natural Gas, the Missing Piece in Minnesota's Electrification Puzzle. This is based on research which we've recently submitted to an academic journal for peer review and publication. My goal is to provide a very brief high-level summary of that work and then give opportunity afterward for Q&A. Before we go into the details, I want to talk a little bit about why Minnesota is really special. So Minnesota has a very unique combination of a relatively large population that also lives in a very extreme climate with extreme weather. This is absolutely distinct among the lower 48 states. If you take Minnesota's 5.68 million people and you multiply it by the number of days those people endure sub-zero weather, you get a value that's about 3 to 4 times larger than any of our peer states in the upper Midwest. So absolutely distinct there. And compared to the rest of the country, there are many parts of the country that don't face this problem at all. Additionally, while we have very efficient air source heat pump and renewable technology that are very valuable resources, they do suffer and degrade in performance during Minnesota's coldest weather. So given these factors, we feel it's very important that Minnesota understands for itself how much new electric energy generation would be needed to replace natural gas. So to make this simple and to keep our estimates conservative, we broke this down into 3 main pieces. The first is peak day demand for gas. So first part of the challenge is to calculate how much gas the entire state uses on its coldest day, because as the state switches from summer to winter peaking, that amount is going to set our capacity requirements. Once we have that in hand, the next calculation is to figure out how much additional electric capacity we would need to cover for that gas demand. Now, this varies depending on the kind of electrification that the state may use, anything from basic electric resistance all the way up to high-efficiency air source heat pumps, other electrification measures, or ground source heat pump equipment. But in general, that equipment also faces challenges at lower temperatures. The COP value is what we use to represent that yellow block, and it's basically for a given amount of gas energy demand, how much equivalent electric is needed. And again, that varies by electrification and efficiency measures. And then the last piece is once we know how much electric demand there would be if we replace natural gas, the question becomes how much renewable resources do we need to provide for that demand in January during the cold weather specifically. There are a number of things we don't address here. We can talk about those later. But our goal is to build on existing work in this area. So fortunately, there is already work that's being done, so we're building, not starting from scratch. There was a 2022 article in Nature that looked at the country as a whole. It found that electrification at 100% would require the United States to add up to 28 times its current wind capacity or 300 times its solar capacity. That's as of 2022. Now, this covered all gas end use cases, but it's not specific to Minnesota, and they use just theoretical COP values, increments of 1, 2, 3. They didn't actually calculate what the COP would be for a given electrification or efficiency measure. On the other hand, there was a 2024 report by Synapse that looked at Minnesota specifically, but they did not look at industrial gas electrification, and they did not take the final step of figuring out the additional electric capacity that's required. But they did find about a doubling of electric demand would occur from 97% electrification. So what did we add in our study? First, peak day gas. We used CenterPoint's internal data on gas throughput on a daily basis and scaled it up for the state as a whole using EIA data. Secondly, we calculated COP values as best we could for residential, commercial, and industrial sectors. These are laid out more in the appendix. It covers 5 scenarios starting from no electrification measure, which is basically electric resistance heating, up to air source heat pumps, higher efficiency air source heat pumps, high efficiency air source heat pumps with envelope improvements, and then lastly, ground source heat pump equipment also with envelope improvements to cover a range of possibilities. And again, those are covered more in the appendix in detail. And then the last step is the Minnesota specific capacity data for renewables in January. We just use average values for the month of January to estimate that. So altogether, we combine these to get a range of conservative estimates for renewables or nuclear that you would need to add to 100% electrify that gas heating load in Minnesota. So summary of the results, we estimate the gas space heating throughput is up to 40 gigawatts in Minnesota based off historical data. And then if you just convert that to electric resistance heating, that would be about 36 gigawatts of new demand. And then with air source heat pumps, you can bring that down 10% with the heat pumps and then an additional 10% in the advanced plus scenario for a total of 20% with air source heat pumps. And then altogether, that is a peak day added load of 29.6 to 35.1 gigawatts. And then the last piece is the additional electric generation assets. So we find that this would require increasing Minnesota's existing electric generation in January by about 4 to 5 times current values. That would be about 24 to 28,000 wind turbines, 35 to 41,000 solar farms, or 29 to 34 additional full-scale conventional nuclear reactors, or some combination of those set of 3 resources there on the right. Again, the full results are in the appendix, but I just would like to say in summary, we found that our results were fairly consistent with the existing literature, particularly the Nature study from 2022.
And then before,
Just a second, kind of a follow-up, just right to that, though. So if you're using as your data bounce is from 2022, has that, like, did that, just being 3 years old or 4 years old from that point, does that capture some of the data center increases in potential demand for on the energy grid? Were you able to calculate that in there or not?
Chair Swedzinski, I'm not sure I understand which 2022 date you're referring to.
Well, you have the, you kind of base it.
Chair Swedzinski, I quickly answer that.
Sounds good.
Joel's work solely looks at the natural gas currently used within the state of Minnesota
Yep.
for heating. It does not include any electrification needed for a future data center,
Or gas
electric
plants.
vehicles, anything. It is solely looking at natural gas that is provided to the state right now.
Thank you.
Oh, no problem. And sorry, before we head to Q&A, I just wanted to thank the committee for their time this afternoon. We appreciate the ability to be able to share this information, how we look to acquire the cheapest BTU to put in our system, also how our infrastructure contributes to affordable and reliable heating, particularly with Minnesota's unique climate. We hope this data and analysis is part of the foundation of future policy considerations here. And now I'm going to really turn it over to Joel for Q&A. Thank you.
Representative Kraft?
Thank you, Mr. Chair, and thank you for the presentation. I do have a bunch of questions. I hope you'll give me some leeway here. So first, before we get into it, Dr. Lynch, what do you want us to take from this presentation? Ideally, what would you like us to take?
Chair Swedzinski, Representative, thank you for that question. Our goal is just to outline what capacity additions would be required in the event that Minnesota decided to no longer have natural gas within its state borders.
Representative Kraft.
Thank you, Mr. Chair. Okay, I appreciate that. So I want to dig into a few things here. Let's start with the study you mentioned on page, the Bonacor one, which you use, where is that? Page 8, I think.
Page 8.
And you picked something from this study to share with us that says it found 100% electrification would require the U.S. to add up to 28x current wind capacity or 303x solar. Things I would just want to point out, the title of the study was, and I quote, "Inefficient building electrification will require massive build-out of renewable energy and seasonal energy storage." I kind of view that as if you want to do it stupid, here's how to do it. And the data that you pick here, this 28x and 303x solar, is it not as if we were to make all the conversion using electric resistance heaters?
Mr. Lynch.
Chair Swedzinski, Representative Kraft, yes, that is up to, that is the upper bound. They do give scenarios in that study for COP 1, 2, all the way up to 6. Yeah, and those are lower. Yeah.
Representative Kraft.
Thank you, Mr. Chair. Yeah, if you go, the efficient one, it's far, far less, an order of magnitude less. So I just, like when you choose to pick out something that is wildly not what is going to happen, I think you cause me to have some questions of the data you're presenting throughout the rest of your presentation. You know, the other thing I want to add that they talk about in this, in Bonacor, is that they say that along with climate benefits, electrification and consequent reduction in combustion energy sources would also have public health benefits by averting air pollution emissions. So I think, you know, cost data and this doesn't take into account the externalities that use of fossil fuels and natural gas cause on society in terms of air pollution, asthma, increased deaths, things like that. Am I correct with that?
Mr. Lynch.
Chair Swedzinski, Representative, thank you for that question. The scope of our study is just trying to look at the resources that we would require. That sort of falls outside of what I'm here to speak today. But if I may follow up on your previous point, in the manuscript, I believe we do talk about the other COP scenarios that are in that study. It was just an abbreviation for time on the slides.
And Chair Swedzinski, Representative Kraft, correct with the Nature Journal. Additionally, through Joel's research, we did look at COP of 6, which is used in some of these things. As articulated earlier, and maybe it was missed, in order to achieve that, particularly through the state of Minnesota, everyone would have to be on a ground source heat pump, the entire T. So that's the max plus value. If you look in the appendix that's there, that is all building improvements, all everything. So while I understand where you're coming from on looking at what is a COP1, currently not a lot of technology is above even a COP1. So looking at the totality of it, the question during peak January, like looking at how efficient an air source heat pumps is, and that is also, I think, something that's missed here, is looking at when is our peak heating needs in the state and addressing what is the COP of the technology then that's usable.
Representative Kraft.
Thank you, Mr. Chair. Okay, so one of the things that you do include in your analysis of, on the gas side is, I think on page, you talked about that with the cost you do a lot of peak shaving, you do a lot of storage to make your network efficient. Is there any peak shaving or storage assumed in the studies that you've been cited or in your study, Dr. Lynch, of how energy will be stored, could be stored in the future?
Mr. Lynch.
Chair Swazinski, Representative Kraft, again, thank you for the question. That is outside the scope, but I would say that our study takes two values, and they're reported in the back of the slides and in the manuscript, a peak day and a peak month value. And a battery system is typically, time constant on those are typically hours, maybe to days with advanced technology. So those things could spread out the peak gas demand from peak day closer to peak month. To go any lower than those values that we reported would require seasonal energy storage, storing from summer and deploying in winter.
Representative Kraft.
Thank you, Mr. Chair and Dr. Lynch. Certainly true for today, but as we look to decarbonize our heating sector and the way we heat and provide to society over the next 10, 20, 25 years, are you making the claim that there won't be something that can provide storage longer than a few hours when we're already testing things that can provide multiple hours? And you could do even something like create hydrogen and then burn that later.
Mr. Lynch.
Chair Swazinski, Representative Kraft, that is a very interesting suggestion. Again, it just falls outside the scope of this study, trying to stick to the data that we compiled.
Representative Kraft.
Thank you, Mr. Chair. There's another comment in here that says, I think relative to peak, about renewable energy and nameplate capacity. I'm trying to find the page. Maybe you could help me with this. Oh, here it is. Page 7. Renewable assets don't perform at nameplate capacity in cold weather. Correct. So I understand that point theoretically. Why don't we look at Winter Storm Fern that hit just a couple of months ago here? And this comes from the Niskanen Center that looked at in SPP and MISO, the nameplate capacity compared to what actually the output was of a variety of sources. And from SPP, gas, from its accredited megawatts, performed at 47% during very cold times, 47%. Wind and solar performed at 205%. This is actual. In MISO territory, it was a bit better. Gas performed at 63% of capacity, wind and solar at 258% of capacity. So theoretically, I understand what your points are, but what we've seen over and over again in extreme weather situations is our gas capability. And by the way, I should start by saying I so appreciate the service that CenterPoint and other gas utilities provide to Minnesota. It's absolutely critical, right? But what we've seen is in these challenging times that gas underperforms. And according to this, which I was kind of surprised at looking at it, wind and solar overperforms.
Is that a question or a statement? Dr. Lynch?
I think, yeah.
Chair Swazinski, Representative Kraft, one thing I would like to note in here is this study isn't looking at electric generation from natural gas. We're solely looking at it as the heating needs. We've backed out from these calculations anything to do with anything that is not non-renewable from a generation standpoint, and have been solely looking at the heating used, or natural gas, that is used for just strictly heating, not for any electric generation. So while I too, during Storm Fern, was looking at MISO and the costs for megawatts, paying attention to all those things, completely understand what you're saying, but it is a little bit of an apples to orange comparison right now on what this report is looking at, versus, because it is not citing any type of electric generation from natural gas.
Representative Kraft.
Thank you, Mr. Chair. Okay, it still is gas performing, whether you're burning it for electricity or burning it for other things, having issues in super cold weather. So, one of my, is your point that this cannot be done Or is your point, is that your point? Is your point that this cannot be done and we cannot come up with a way to figure out how to, with a variety of tools, to decarbonize our heating?
Dr. Lynch?
Chair Swazinski, Representative Kraft, appreciate the question. I'm here on behalf of the natural gas utility. We're trying to present data. It's respectfully up to the committee to decide what we should or should not do.
Ms. Fiske?
Chair Swazinski, Representative Kraft. My closing statement here before going to Q&A was to provide this information to hopefully be part of a foundation of the conversations that we have moving forward in Minnesota on policy. I think it's great when we use data and analysis to be informative, and then to also understand maybe some of the unique and special needs that our state faces compared to other states.
Representative Kraft?
Thank you, Ms. Chair, and I appreciate that. That's, we do have to deal with a different situation. What I would say, though, to summarize here a couple points, is when I asked about, this is interesting data, but when I asked about, are we looking at energy storage and what was the other point? Are we looking at energy storage and peak shaving, for example, right? Virtual power plants, how can we, with the grid of the future, as these things come onto the grid, right, we need a different kind of a grid. And so you're using that to look at your gas capability, but not on the side of what happens in the future with the grid. So it's one-sided in that you do storage and you do peak shaving on the current gas facility, and you're not assuming any on the electric grid side. The other thing I will say is, as I looked at some of these studies, part of it is it's what you have to deal with, but so much of the analysis is what's our grid today and backward looking. The grid of the future and what we need is very different. And here's a way of thinking about it, and I guess there's not a question in here, but here's, as I think about this, you have gas peaker plants today, right? And when you have excess capacity, you don't use it, right? Because it's going to cost money, right? With wind and solar, as we build out a grid like this, and when there's excess capacity, you use it whenever you can because the marginal cost, that fuel cost, is pretty much zero. So on top of, to really get what, the other thing I would say is, if you look at some your most aggressive conservation scenarios, even without thinking about peak shaving and even without thinking about storage, said we need about double the grid that we have today. That seems about right. We need to grow our grid. We're going to need to generate more electricity. But with a grid based on renewables and with excess capacity, it's also an opportunity for us to do things like green fertilizer, green steel, sustainable aviation fuel, because when those excess is there, it provides very free, low-cost energy. So I really appreciate the analysis here. I think it's you're missing a side of it, right? It's one-sided, and it's not really looking at what the grid will actually be like in 10 to 20 years.
All right, Ms. Fiske?
Thank you, Chair Swazinski, Representative Kraft. One item I did want to clarify is maybe the confusion that we're having with storage. Storage, at least from the natural gas side of things, is done so more for economics, not necessarily storage done from the electric side from a battery. So just, again, it's a little bit of an apples to orange comparison here and how it was being associated. So I just wanted to clarify from our perspective, storage is typically done from an economic standpoint where you store it when you can buy it cheaply and then dispatch it as needed. Not necessarily during.
Thank you, Mr. Chair, because I was reading that part of the thing that enables on super cold days is to access some of that storage when gas may be harder to provide gas. So you're saying that's not the case?
Saying typically, I'm sorry, Chair Swazinski, Representative Kraft. Quite often, storage is more used for an economic standpoint than used as a capacity constraint. It can be, but really that's why storage exists, at least for the natural gas side.
Dr. Lynch, did you have something to add to that?
Chair Swinsky, Representative Kraft, I just wanted to follow up on one point that you made. The doubling of the grid in the Synapse report is electric demand, and that is different than whether or not you would double or more the actual renewable assets, again, because they are operating differently at those cold conditions.
Representative Kraft.
Thank you, Mr. Chair. Can you repeat your last sentence? Operating in what?
Dr. Lynch.
Chair Swinsky, Representative Kraft. So it's a doubling of grid demand that they reported. That is different than the multipliers that we show on our final slide. For example, the 4 to 5. I just want to make sure that was clear because we're talking about the additional January capacity that you would have to add to the grid, and that is different than the energy or electric demand.
Representative Kraft.
Thank you, Mr. Chair. And I would just say, so yes, but again, you're not assuming that there's any capability of storage or peak shaving in what's happening on the grid at those times.
Dr. Lynch, sorry.
Chair Swinsky, Representative Kraft. Again, that goes back to we report both peak day and peak month to sort of bookend those values.
Representative Kraft.
Thank you, Mr. Chair. Yes, but you're still, are you saying that because you're saying, well, look, batteries today can only do a number of hours, and so we're not taking it, and so by using your peak month, you're not taking into account? I'm saying there's a lot of work being done on long duration storage, and if you're talking about something that's 10, 20 years out, not that you can model it, but that is something that is missing in your analysis.
Dr. Lynch.
Chair Swinsky, Representative Kraft. So in our analysis, we are giving sort of two ranges of values. One is the high end, which would be the peak day. If you did build out battery storage, we're not estimating how much, it would allow you to shift that down to the peak month that we also report as well. So it would be somewhere between those two, yes.
Thanks.
Representative Kraft, that's it? All right. Representative Hollins.
Thank you, Mr. Chair. And thank you for the presentation. I thought it was really interesting, and this line of questioning has been interesting too. I feel like I would be remiss if I didn't, as the author of the TENS bill, if I didn't mention thermal energy networks as a part of what we hope to be our clean energy future, or just energy future, because actually we know that geothermal is significantly more efficient than gas or electricity. And I noticed it wasn't included in any of the discussion that was happening, and I was just wondering why that was.
Ms. Fiske.
Chair Swedzinski, Representative Hollins. And again, this is sometimes where technology falls into too many different names, but the same thing. Thermal energy networks, network geothermal, and then here the MAX, which is like a ground source heat pump. That is that. So when we were referring to ground source, or I think it's under the MAX scenario, they look at, which would be if everybody had a ground source heat pump, GHSP, or what it says in there. So that is part of this, and again, I feel like there are so many things that are the same thing, but now named different things.
Representative Hollins. All right. Are there any other questions? Representative Sexton?
So I'm looking at slide 11, if anyone want to reference that. And even if we stop building pipelines right now and switched and built everything electrical, the numbers that we would need to build are somewhere between what you've already listed as peak, because that's replacement, and what we have today. I'm just trying to calculate out how much transmission we would need, say if we had 15 nuclear power plants. I mean, that is significant amount of steel that's going up in the air because you can't put that underground. Any comments? I realize you're a mechanical engineer, but I know you do a little electrical on the side.
Dr. Lynch, do you want to grab onto that wire?
Chair Swinsky, Representative, thank you for the question. We were trying to come up with conservative estimates, so as part of that, we're leaving out transmission and distribution losses. That would certainly play a role as well. It gets into a much more complicated, detailed study that would have to be done at a later date.
Representative Sexton, anything else? All right. Sounds good. Thank you very much for your presentation. I'm sure you'll be available for other questions if we have things offline. Appreciate your research and appreciate your presentation today. All right. Members, the next meeting is Tuesday, April 14th. Cherrycombe will have the gavel. It's going to be a doozy. End quote. And seeing no further business that's come before us, this meeting is adjourned.